All right, to finish up this section that we've been working through, we've got one kind of new piece of information that we're going to add in. But we're also going to go back and we're going to review again factoring and a little bit of graphing just to kind of instill what we've been talking about this entire section, to kind of throw it all together in one big piece. So the new piece is if instead of giving you the equation, so like x squared plus, so instead of them giving you like x squared plus 2x minus 5 or something like that and you had to factor it, what they're going to do instead is give you the roots, give you the zeros, the solutions, and they want us to write the equation out. Okay? So for this first one, we're given the zeros 3 and 4. In order to get it started, we got to write it like in parentheses so that it's x, x, and then our numbers. Now to do this with the 3 and the 4, you're always going to do minus signs. Okay, so it's going to be x minus 3, x minus 4. The reason for that is we think about when we solved those equations. If I was solving this, if this was my factored form and I set them equal to 0, how I got 3 and 4 is I would have added 3 and I would have added 4 after I'd set them equal to 0. So you have to set them with the minus sign so that they're the opposite when you're actually factoring them. So once you've got it written like this, to get to your quadratic form then, we use our FOIL method. First, outside, inside, last, which we talked about that earlier this chapter. So we're going to start by doing x times x, which would be x squared. The outside terms would be x and the minus 4, so that would be minus 4x. Inside terms would be negative 3 and x, so minus 3x. And last would be negative 3 and negative 4, which is positive 12. Last thing you can do is combine the middle terms. You've got negative 4x and negative 3x. What's going to be negative 4 minus 3? Good, so we have x squared minus 7x plus 12. That's all there is to it. Okay, so if you remember how to FOIL, this shouldn't be too terribly difficult for you, because you're just multiplying using like that distributive property twice. But we use that first, outside, inside, last to kind of help us so we don't have to draw a bunch of arrows. Now, if you have a root, like on number 2, that starts out negative, so like this one I have 5 and negative 4. When I start with my parentheses, just like we did on the last one, drop an x into each one, and then minus signs. So it's going to be x minus 5, and then x minus negative 4. What do you guys think is going to happen to that second one? It's going to turn to a positive. So I'm going to rewrite it so it says x minus 5, and then x plus 4. And again, if we think about this, if we were to set those each equal to 0, so x minus 5 equals 0, we would add 5, and that's how they got positive 5. If I set x plus 4 equal to 0, I subtract 4, and that's how they got the negative 4 up there. So it still is making sense with the roots that they gave me. Now, again, I'm going to FOIL. Okay, so you guys take a minute and FOIL this out, do that multiplication, and write down what you think the equation should be. You guys want to tell me what you got? Anybody else get that? Good. Looks like some of you are nodding your heads at me. Okay. So first term would be x squared. To get that negative x, you have a negative 5x and a positive 4x. So when you add negative 5 and 4, that's how you get negative 1. And then you're minus 20. All right, let's turn our page over. We're going to do some extra practice here with factoring. So remember I said yesterday that when they talk about solutions, they might call them zeros instead. Another word that they could use are called roots. So there's a lot of ways that they could be talking about, like, solve this quadratic equation. They could say find the solutions. They could just say solve it. They could say find the zeros. They could say find the roots. Okay, all of those things mean the same thing. Figure out what values of x would cause this to become a big zero. Okay, so we're going to try to factor. Now this first one, since it's just x squared, there's not a number sitting in front of it. We don't have to worry about doing our long factoring. We can go ahead and just factor this out. So you're thinking of two numbers here that would multiply to that 50 at the end and add to that negative 15 in the middle. Can you guys think of two numbers that would do that? Five and 10. Do we want them to be negative or positive or one of each? Good, both negative. Okay, so we get positive 50 when we multiply and then negative 15 when we add. So when I factor it, I'm going to do x minus 5, x minus 10. I'm setting them equal to 0 now. So then set them each equal to 0. X minus 5 equals 0, x minus 10 equals 0. What are my two answers going to be? Good. X equals 5, x equals 10. For number 2, we have 4x squared equals 25. Let's get these on the same side of the equal sign first. So remember I said I like to keep the x squared term positive if I can. So in this case, I don't really want to move the 4x squared term because the 4 is positive already. So instead, I'm going to move the 25, and I'm going to do that by subtracting it. So I'm going to subtract 25 from each side. So we have 4x squared minus 25 equals 0. Do you guys remember what I told you to do on one that looks like this? So see if there's anything that you could take out. Is there anything that 4 and 25 share? No, they don't have anything in common. But is there something that you guys notice about the numbers 4 and 25? They're perfect squares, right? Can I take the square root of 4 and get a whole number? And can I take the square root of 25 and get a whole number? So because they're both perfect squares, this is one of those special cases. So I'm going to drop parentheses here. What is the square root of 4? 2. So each set is going to get a 2 and an x. So we write 2x down. The square root of 25 would be 5. And what goes in the middle? Good. Positive and negative. So one of them gets a plus sign, one of them gets a minus sign. Because we've got no b term, again, there's no x term, those middle terms, when I FOIL it, had to cancel. So that's why we need one of them to be positive and one of them to be negative, so they get opposite signs and they cancel each other out. Now, when I set these equal to 0, so when I take it that step further and solve them, I'm going to get fractions for these answers, and that's okay. I'm going to subtract 5 on the left one. So I have 2x equals negative 5. Divide by 2. So one of my answers is going to be negative 5 over 2. I'm going to move this one over a little bit. For the second one, the solving looks pretty similar, except you start by adding 5 instead of subtracting it like we did over here. So we have 2x equals positive 5. Divide by 2. So the other answer is positive 5 over 2. That should happen with the solutions on cases like that, where you've got the difference of two squares. You get the same number, you just get one positive and one negative. Because the pieces inside the parentheses are exactly the same, except you had one with the plus sign and one with the minus sign. All right, now if we look at number 3, this is going to fall more into what you were talking about a little bit ago when you said take something out that they have in common. What do you guys see that they have in common? Just an x. What's left if I take out an x, though? Good, x plus 8 equals 0. So what are my two answers going to be for x? Good. The first one is just x equals 0. The other one's going to be negative 8. All right, we're going to finish up here with one last example of graphing. So for this function, they want us to find the following things: the vertex, the y-intercepts, the zeros, and the graph. All right, so for part A, to find the vertex, remember that's when you want to do your negative b over 2a like we were doing yesterday. From your guys' equation, can you tell me what the b term would be? What number is in the b spot? 2. So we're going to do negative 2. What number is in the a spot? 1. So we're going to have negative 2 over 2, which would be negative 1. So then we take negative 1, we plug it in to that equation. Okay, so you're doing 1, negative 1 squared, plus 2 times negative 1, minus 8. So if you really want to simplify this down, negative 1 squared is 1, then you're going to have minus 2, and then minus 8. So we're going to get negative 9 when we do that math. 1 minus 2 minus 8 is going to be negative 9. So vertex is going to be negative 1, negative 9. So there's part A. Part B wants the y-intercept. How do we find that point? So that negative 8 at the end is your C. How do we write it as a coordinate? Good. 0, negative 8. Now, to find your zeros, yesterday what we were doing is we would have made a table. Okay, what I'm going to do is just factor this, because this looks like it would be a simple one to factor, because I've just got x squared plus 2x minus 8. So I'm going to go ahead and do my two sets of parentheses, drop an x into each one. Now I'm thinking to myself, I need two numbers that multiply to negative 8, and they have to also add to a positive 2. So what two numbers are going to do that? They're going to multiply to a negative 8. Good, and they're going to add to a 2. So positive 4, negative 2. Then if I set these equal to 0, just like what we were doing a little bit ago, you set x plus 4 equal to 0, x minus 2 equal to 0. It just flips their signs. So you get x equals negative 4 and x equals 2. Those are your zeros, which means that, like as a coordinate, because I'm going to have to graph this, they'd be negative 4, 0, 2, 0. Because that's where they're on that x-axis, like we saw from our charts yesterday. All right, and then for part D, I'm going to graph it here. So let's see, my zeros are at negative 4 and 2, so I'm going to go ahead and draw those points in. We said that the y-intercept was at 0, negative 8, so I'm going to come out a little bit here because I'm going to need some more room. So there's the y-intercept. My vertex is at -1, -9. So right there. I'm going to go ahead and reflect the y-intercept point, that's 0, -8. It's 1 to the right of the vertex, which means that the reflected point should go 1 to the left. Remember, that's when you think about that imaginary line that's cutting through the middle of your graph, and it acts like that mirror line. And then we should go ahead and be able to connect our dots here and see our quadratic, our parabola. And there it is. Now, if it was an equation that maybe wasn't as easy to factor, so if it had like a number other than 1 in front of x squared, so if you saw like one of those 2x squareds or 3x squareds that would, factoring wise, would make you have to do a times c, then maybe I would suggest, if you're graphing, use a table instead of trying to factor it, because the table is going to be slightly quicker than having to do that a times c method. This one I factored because it was fairly easy and fast for us to do that. So I didn't need like a whole big table for me. Okay, so you've got some options now when it comes to solving. If they do ask you to graph, make sure that you're providing the graph with it. But if they're kind of leaving it open and they're saying solve it, and they don't really tell you how, you can decide what you think would be easiest, whether it would be factoring, graphing. And most of the time I'm going to say, if they tell you what to do, like they don't tell you what to do, it's probably easier to factor than to graph, because graphing just takes a little bit extra time, unless you're doing one of those longer factoring problems.